Section 9.3, Geometric Sequences. The objective of this section, to define, identify, and apply geometric sequences. Lesson vocabulary: geometric sequence, common ratio, geometric mean. An essential understanding: in a geometric sequence, the ratio of any term to its preceding term is a constant value. In this problem, we're asked to find the fifth term in each of these number patterns, and then asked, can you tell what these sequences have in common? And explain your reasoning. So first, let's consider pattern A. 3, 6, 12, 24, 6. Well, it's not an arithmetic sequence. Remember, in an arithmetic sequence, we would have a common difference, or we would be able to add the same thing repeatedly to each term to find the next term. If this were an arithmetic sequence and we consider our first two terms, 3 plus 3 is 6, but 6 plus 3 is not 12. And so therefore we know this is not an arithmetic sequence. Perhaps 3 times 2 is 6, 6 times 2 is 12, 12 times 2, 24, 24 times 2, 48. Very good. B, 1/10 or 0.1, 1/100th or 0.01, 1/1000th, 0.001, and 1/10,000th, 0.0001. Well, this pattern seems pretty obvious, even if we don't recognize that we can multiply each of these values by 1/10 to get the next value. That could also be thought of as dividing each of these by 10 to get the next value. But just looking at the pattern visually, we would see that we're adding a 0 each time. And so our next term, first, second, third, fourth, our fifth term would be, trying to squeeze it into the space provided, 1, 2, 3, 4 zeros, not going to fit. 1, 2, 3, 4 zeros and a 1. So it'd be 1/10th, 100th, 1000th, 10,000th, 1/100,000th, and C, 1/3, -1/9, 1/27th, -1/81st. Well, I notice definitely a positive, negative pattern, so I know that the next value will be positive. I recognize also that it will be a fraction, so I'll place a fraction bar in place. I notice the numerator is always 1, or potentially we could think of that as 1, -1, 1, -1, but a 1 numerator. And I notice the denominator, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and 81 times 3, $243. And therefore our next term in the sequence is 1/243rd. So now the question asks, can you tell what these sequences have in common? Well, as I've pointed out, well, in at least sequences A and B, we can think of this as multiplying each term times some constant value in order to get the next term. The same is true for C, even though I didn't describe it that way. 1/3 times -1/3 does equal -1/9. Notice that's our second term. Now -1/9 times that same common value, that constant -1/3, well, a negative times a negative is positive. 1 times 1 is 1, and 9 times 3, 27. This third sequence can also be thought of as simply multiplying each term by a value of the same constant value to get the next term throughout the sequence. Example problem 1, identifying geometric sequences. Is the sequence geometric? If it is, what are A sub 1 and R? Well, A is 3, 6, 12, 24, 48, and so on, well, it's pretty easy for us to identify as being geometric. We simply multiply each term by 2 to get the next term, thus telling us that our common ratio, or R, equals 2. And a sub 1 would simply be our first term, 3. B, 3, 6, 9, 12, 15. Right away I recognize this as being an arithmetic sequence, meaning that it's not geometric. You could identify a sub 1, though I'm not sure we're required to if it's not a geometric sequence. But a sub 1 equals 3 once more. But there is no R value. We have a common difference, not a common ratio. So R does not exist. And let's check out the book's response. The ratios are different. With no common ratio, the sequence is not geometric. And C, 3 to the 5th power, 3 to the 10th power, 3 to the 15th power, 3 to the 20th power. So let's really consider what's going on here. Well, if our first term a sub 1 will be 3 to the 5th power. The question is, what must we multiply 3 to the 5th power by to get 3 to the 10th power? Well, 3 to the 5th power is, let's just leave it this way, or written this way. 3 to the 5th times what equals 3 to the 10th power? And this is really our question mark here. 3 to the 5th times, think back to rules or properties of exponents. When we're multiplying the same base times a certain exponent, the same or otherwise, we add the exponents. 3 to the 5th times 3 to the 5th equals 3 to the 10th power. And that makes sense because of this other property, 3 to the 5th squared. If you recall a power to a power, well, that's when we multiply. So we'd multiply the exponents 5 and 2 to get 3 to the 10th power. So that makes good sense. But if this is the case, and this is a geometric sequence, then 3 to the 5th power is not only our first term, our a sub 1 value, but it's also our R value, our common ratio, that thing that we must multiply by each time to get the next term. So let's test that out. Could 3 to the 5th power be our R value? 3 to the 5th. I'll put a question mark here for the time being. I'm tempted to look at the bottom of the page, but I'm not going to. 3 to the 5th power, 3 to the 5th times 3 to the 5th is 3 to the 10th. The big question is 3 to the 10th power times 3 to the 5th power, I'll just write them this way without parentheses, equal to our next term in the sequence, 3 to the 15th power. This is looking good. Adding those, yes. So it turns out I can erase that question mark. Wow. That eraser's a little big. I can scribble out that question mark using the pen tool, or perhaps I can scribble out that question mark using the pen with white ink. And find that yes, this is a geometric sequence with an a sub 1 of 3 to the 5th power and a common ratio of 3 to the 5th power. But do you got it? Well, here's your chance to show whether or not you do have, whether or not you've got it. Question 1 of 3. Is the sequence 2, 4, 8, 16, etc. geometric? If it is, what are a sub 1 and R? Of course, you should work carefully and make your selection from the choices below. Question 2 of 3. Is the sequence 1, 5, 9, 13, 17, etc. geometric? If it is, what are a sub 1 and R? Work carefully. Make your selection from the choices below. And got it, question 3 of 3. Is the sequence 2 to the 3rd, 2 to the 7th, 2 to the 11th, 2 to the 15th, etc. geometric? If it is, what are a sub 1 and R? Work carefully. Make your selection from the choices below.